So the maximum INL formula is Vref by 2 into delta Rk by R. So for 1% mismatch, this delta Rk by R value is 1%. So for that, then we can write the INL max for that case as INL max is equal to Vref divided by 2 into 0.01. This is how we can find the maximum INL. Now, after getting the maximum INL, as we stated before, for a DAC or ADC to be n bit accurate, we are looking for maximum INL or DNL within the range of 0.5 of LSB. So that check we should always do in order to make sure that the DAC or ADC is n bit accurate. If not, the DAC is not considered as a DAC or ADC with that much resolution. The resolution is actually smaller to that or lesser than the value what we actually say with respect to n. Alright. So the worst case INL in this cases can be written as Vref by 2 into delta Rk by R. Let us quickly look at this question based on the discussion what we have done. The question is, determine the effective number of bits for a resistor string DAC, which is assumed to be limited by the integral nonlinearity. That means there is INL error. The resistors are passive polyresistors with a known relative matching of 1%. So 1% is the matching error and the reference voltage is 5. So how do you find the effective number of bits? Effective number of bits is nothing but, for now what we consider the effective number of bits is nothing but the resolution. Resolution in terms of number of bits. So how will you find it? So we have the relation here, the INL max relation. So INL max can be written as from this the above the expression what we have written, Vref by 2 into delta Rk by R, right? So Vref by 2 into delta Rk by R, which is nothing but the percentage matching. The mismatch, right? So this can be written as Vref by 2 is 5 divided by 2 into the mismatch is 1%. So 1%. So you will get the maximum INL. What is the maximum INL value? INL max is what is the maximum INL? Is 2.5 into 0.01. Yeah, it is 0.025 volt. This is the maximum INL, right? Now what is the question? The question is to find the effective number of bits or the resolution of this DAC, which is having which is limited by its INL, and the maximum INL we calculated from the worst case scenario, which is equal to 0.025 is now for a DAC or ADC to be n bit accurate, we can write that the maximum INL should be equal to plus or minus 0.5 of LSB. This is what the condition is to consider that the DAC or ADC is n bit accurate, right? So what I can do here is, we have the maximum INL formula here, which is equal to 0.025. So 0.025 value we have, that is equal to half of LSB. LSB is Vref divided by 2 to the power of n. Now half of that is 2 to the power of n plus 1, right? Vref is there as 5. So from this we can estimate what is the value for n. What is the value for n? From this maximum INL, we are I think you will get it as 6.64, right? N is closely equal to 6.64. If you are getting at 6.64 in this case, what you can do is, see, your maximum INL is 0.02. We have taken the worst case scenario, and with that you are getting 6.67. So if you round off it to 7, definitely that will give you some error, right? Error in the sense it is only 6.64, it is not even 7. So in this case we can say that the resolution is 6 bits. Under the worst case scenario, the resolution can be only up to 6 bits, because if you consider 6.64 as 7, we don't have 7 bit resolution, right? We have taken the worst case scenario, and based on that, the resolution what we have is up to 6. Alright, I hope this is clear. So we have considered INL, the worst case INL scenario. Now when you compare with this DNL and INL, INL is having a major effect on this resistor string DAC, because for every mismatch you will have, so we have even considered the worst case INL scenarios, right? Because the INL, the integral nonlinearity can actually vary a lot, because there is mismatch in every single resistor what we use. So compared to INL, DNL is not much issue, because DNL is purely depending on the ideal step height and the actual step height. So DNL is not that concerned as high as INL. But anyway, we will look at the differential nonlinearity also for the worst case resistor string DAC based on the discussion what we have done now, right? So what we learned about DNL is DNL can be obtained as the actual step height for an n-bit transition minus the ideal step height. This is how we generally find DNL, right? So previously for the INL calculation, we have the actual voltage, we have written the actual voltage, we have also written the ideal voltage. Now to find the actual step height, what we should do? To find the actual step height, I should have the actual voltage for a specific position, say Vi, and the actual voltage for the previous bit, the previous position or the next position, right? That is how I can calculate the step height. So step height is calculated based on two adjacent input digital code word transition. So if I am considering for the ith resistor, the corresponding to the for I, then I have to consider either I plus 1 or I minus 1. So I am considering two adjacent input digital code word, and I am trying to calculate the actual step height, right? So what I am doing here is, to get the actual step height, I am taking this difference. So I hope it is clear. So this is the ith position. Say you have this level. Now this is I, say this is I minus 1. So what I need to find is this step height, right? So if I know this voltage and this voltage, the difference between these two will give you the actual step height, right? So when I calculate this actual step height, I should include the what I should include the mismatch. The mismatches I should include here. Now how will you get the actual step height based on these two voltages? We already have the expression here. What is the voltage? The actual voltage is this. The actual voltage expression is this. I will take the same expression here, and based on that expression I will write the step height. So look at this, Vi minus Vi minus 1. So what is Vi? So Vi can be written as I into Vref divided by 2 to the power of n. What I am writing is based on the formula what we derived yesterday, plus Vref divided by 2 to the power of n into summation k is equal to 1 to I delta Rk divided by R. This is for the ith position. Now I want to deduct this from the I minus 1 or the previous position. So what I am doing is Vi minus Vi minus 1. So what I should do on the right hand side, I should just include or just replace I with I minus 1, right? So minus, to get the previous value, I minus 1 into Vref divided by 2 to the power of n plus Vref divided by 2 to the power of n. The summation k is equal to 1 to I minus 1 delta Rk divided by R. This is in brackets. This is Vi minus Vi minus 1. Now look at this. You have Vref by 2 to the power of n. Here also is there. So we'll cancel those two terms, because this becomes minus Vref by 2 to the power of n. So and even from the second term, you will have, okay, let me just write this. When you take this difference, the result what you will get is this. From the first term you have a Vref by 2 to the power of n, and from the second term difference, here it is Vref by 2 to the power of n summation k equal to 1 to I delta Rk by R. Here also the same thing, but only the difference is summation is I minus 1, right? So what will be the difference? You will have this Vref by 2 to the power of n will be there, then again one Vref by 2 to the power of n, and this difference, and that difference will give you delta Ri by R, because till delta Ri minus 1 both will get cancelled. The only difference is delta Ri by R, or this can be written as Vref divided by 2 to the power of n into 1 plus delta Ri divided by R. Is this clear? Can I get some response from your side? Can I get some response? Yes. Now this is Vi minus 1, and this is the actual step height calculation. Now what is the ideal step height? Ideal step height is equal to 1 LSB. Which is equal to Vref divided by 2 to the power of n, right? So therefore I can write DNL as the first Vref divided by 2 to the power of n into 1 plus delta Ri by R minus Vref divided by 2 to the power of n. This can be written as Vref divided by 2 to the power of n into delta Ri divided by R. 2n plus 1. I didn't get the question.
So for 1 LSB, isn't it 2 for n plus 1?
No, that is half LSB, right?
Yes, sir.
Yeah. So the DNL value is Vref divided by 2 to the power of n into delta Ri by R. Since we have taken the, so this can be considered as the maximum DNL also with the mismatch. Vref divided by 2 to the power of n into delta Ri divided by R. Alright. So this is a calculation, or this is how we can generalize differential nonlinearity for the worst case resistor string DAC. Alright, so we have considered the mismatch in the actual step height calculation for I and as well as I minus 1 position. Alright, so now if this is clear, can you just try this? This question. The question is 8-bit resistor string DAC. Alright. I've taken this question from a book. So the figure is nothing but the resistor string DAC. Yeah. The same resistor string DAC with the binary switch array, right? So the question is with the nominal resistance value of 1K. Now the process was able to provide matching of resistors to within 1%. So the mismatch is only 1%. The question is find the effective resolution of the converter. What is the maximum INL, maximum DNL of the converter, assuming reference voltage as 5. Alright, so can you just try this question and tell me how to go about this. Given that the resistor string is 8-bit, now at the end we should also see with 1% mismatch with the maximum DNL INL calculation, whether the DAC is able to provide or the effective number of bits of the DAC or the resolution of the DAC is whether it is 8 bits or not. We have to just see. So how will you start? So certain things we can definitely find, right? So one thing is we have a DAC. Based on the given information, we can actually calculate the one LSB. LSB is the least possible change or the minimum output voltage change possible in this DAC, right? So that is a calculation which will even help for the rest of the things. So we can actually calculate the 1 LSB value. What is 1 LSB value? 1 LSB value is Vref divided by 2 to the power of n. So based on the information given as 5 and the number of bit as 8, this is 5 divided by 2 to the power of 8, which will be equal to what is the value? So what is the value here? 0.0195. Yes, this 0.0195 volt, which is 1 LSB value, right? Now what else we can find? We have 1 LSB value. Now we need to check whether we need to find the effective resolution. At the same time, that resolution is we can comment on the effective resolution by again looking at the INL value or the DNL value. So let us find the maximum INL value. So what is INL max? INL max, as per what we have written before, what we wrote before is INL max is equal to Vref by 2 into delta RK by R, right? That is how we wrote this. Or this can be also modified, or this can be written in other terms. Let me just take that formula and we'll modify it here. INL max can be written as Vref by 2 into delta RK by R, right? Or this can this is okay that we can actually use this formula. Yeah, let us use this only. No need to change it further. We have the value as 1%. So can you tell me what is INL max? This can also be written as, in terms of LSB, I can write this as half LSB into 2 to the power of n into this delta RK by R. This is another way of writing it, right? So based on this, if you calculate, you will get the maximum INL value. What is INL max? It's 0.025, right? 5 by 2 into 0.01. Are you getting this answer? 0.025, which is INL max. Right. You can also calculate DNL max. What is DNL max? DNL max is Vref by 2 to the power of n into delta Ri by R, right? So you can write that also here. DNL max is equal to Vref divided by 2 to the power of n into delta Ri by R, which is equal to 5 by 2 to the power of 8 into 0.01. So you will get the DNL max value as well. Are you getting these answers? INL max is this, and what is DNL max? Can I get some response in the chat? Maybe I don't know due to my whether my internet connection is slow. Your responses are not getting reflected this side. Yeah, Sriniket, 0.000, yes, 0.000195, which is the maximum DNL. All right, yeah, 1 point, it is 19.5 millivolt, right? Yeah. Oh, yeah, it can be also written in terms of LSB as 0.01 LSB, that is fine. So we obtained the maximum INL and maximum DNL. Now, from the previous discussion, I also mentioned that INL is more deciding factor with respect to the resolution of this resistor string DAC is considered than DNL. So, give me a minute. Yeah, so now we will find the effective resolution based on the INL value. So we have the INL result here, and we also understand that INL is actually the limiting factor in the case of a resistor string DAC. So keeping that in mind, in order to find the resolution for the DAC, what we know is the INL max should be max equal to half of LSB, right? Yeah, so based on that, if you calculate, so the calculation is same as the previous one. So we have this maximum value here. The maximum value should be equal to 0.5 LSB. Yeah, you can calculate as same as how we did for this question, right? From the maximum INL, you can go ahead and find the number of bits n. So 0.5 LSB is equal to Vref divided by 2 to the power of n plus 1, whose value is here. Based on the value, we can find the value of n. So we will get the value of n from this. So what is the n value? Are you getting the value of n? Your n will be approximately around 6.64. I think approximately around 7. Yeah, 6.64 is what you will get. So you are getting 7.64. Can you check again? Yeah, 6.64. So based on the INL calculation, when we calculated the effective number of bits, it is only 6.64. So even though the DAC was designed, even though the requirement was an 8-bit DAC, because of the mismatch in the resistance, a 1% mismatch, even though the DAC is 8-bit, the effective number of bits or the effective resolution what we will get will be only up to 6 bits, right? And the reason for that is the mismatch in the resistor values, right? So this is how DNL or INL will affect the resolution, and this is how the mismatch in the components of a DAC. We have considered only one DAC as of now, but still based on the based on the mismatch in the resistors, this is how it will affect the linearity DNL INL. In turn, it will affect the effective number of bits, right? So for today we'll wind up here, and this is all about resistor string DAC. And next we will start with the next type of DAC, which is R2R DAC. All right. So if you have any questions based on the discussion we have done, you may please ask.